Hope, dear students, that you are fine. I hope that you have practiced this question which was given on the Telegram channel. So let's try to solve this, and let's see also the other possible products which will be formed, but they are actually the minor. You have to always tell the major product and the actual pathway, right? So let's see the mechanism and the product formed here in this reaction. So first of all, in this first step, what is given here? This is just the alcohol here. The functional group is OH, and this is the acid given. So whenever there is acid and there is OH, so oxygen, it has lone pair electrons on it, right? So definitely what will happen? It will just give these lone pairs to this H positive. So it will just form the protonated water. And then water is a good living group, so that will easily leave from this molecule. So let me show it here. For example, if I will just write this is my cyclopentane here, and after the attack of this proton here, what it will become? It will just become OH2 positive. Whenever oxygen, it is normal valence is 2, but it has now formed the 3 bonds, 2 with the hydrogen and 1 with this carbon. So there will be now positive charge. It's now electron deficient. So here we were having the methyl group attached to this, so you can show it like this. So we are having here the methyl, right? So after the attack of water, now what will happen? I told that this water, it's a good living group, so it will just take these 2 electrons towards itself, so it will just leave. So we will show it here, minus H2O. What we will get? We will get just the carbocation, right? So this is now very important. This is the reaction intermediate which is actually formed here, and the carbocation reaction intermediate which is formed here, that is your primary carbocation. It is here just CH2, and it has now positive charge on this, and we are having also the methyl group attached to this here. So you already have studied that whenever primary carbocation is formed, what it will undergo? It will undergo rearrangement in order to stabilize, because we know the order of stability of carbocations. It is, we know that tertiary is more stable than secondary and then primary. So now the 2 possible arrangements are here. Either there will be methyl shift. If methyl shift is here, then the carbocation will get shifted here, so we will get the tertiary carbocation. But another possibility is that there will be the ring opening. This is the 5-membered ring. So if ring opening takes place, then we will get the 6-membered ring. And we know that whenever there is a ring opening possibility, so we have to first open the ring, because this ring is having strand. It has angle strand in it. So that's why this is the 5-membered ring. So we will make the 6-membered ring here. So let me show the both possibilities. First of all, if a methyl shift takes place, then we will get species like this. That is carbocation, it will just get shifted here, and methyl will come here. Just methyl shift, and here we will get the tertiary carbocation, right? So another, I told that ring opening will take place. So this was just the methyl shift. Methyl has got shifted to this here. Now the another possibility is that this ring opening will take place, right? For example, if I will show it like this, that is, this bond will break and it will join with this positively charged carbon. So what we will get? We will just get the 6-membered ring. So that is just like this. This will be the 6-membered ring formed, and here it was the methyl. So this will be here the positive charge. Now if you see, this is your tertiary carbocation, and the above one is also your tertiary carbocation. So now which is more stable? So definitely, if I will just call this as first and this as second, so definitely second is gonna to be the major one, because this is tertiary. Along with that, a ring opening has taken place. It is more stable. There is less angle strand in this 6-membered ring. And I hope that you know that this 6-membered cyclohexane, actually it exists in the chair form. Chair is the most stable conformer of cyclohexane. So right, so now this will be formed as your major. So second is your major, so that is why it will result in the formation of product. Now what will happen to this? Simply it will just there will be now beta elimination. So that is, see this carbon here is the hydrogen attached to this, right? Hydrogen. So hydrogen will just get eliminated in the form of H positive, and it will just give 2 electrons here. So double bond formation. It's just formation of double bond. So I will show it like this. So you will just get here the alkene. cycloalkene it is here. So here it is the methyl group. So this will be your X. So this is your X. So I hope you have understood that how this X is formed. Simply, first of all, protonation takes place. So after protonation, this water will get eliminated. It is a good leaving group. You will note down that it is a good leaving group, right? So after that, it will form just the carbocation, and there will be now rearrangement from primary carbocation. It gets converted to tertiary, but how? By ring opening. Whenever there is possibility of ring opening, you have to open the ring, because whenever there is more stranded ring like 3-member, 4-member, so at that time you have to actually see all the situations. So in this situation, 5-member, it gets relaxed to the 6-member ring. So this is more stable here as compared to the first one. So we get this X as our alkene. Now after this, there is ozonolysis. We have to react this alkene with the ozone, right? So I hope you remember the ozonolysis of alkene. So let's see on the next page. So we are having just, this is our alkene here, and we have to treat it with the ozone. And we know that whenever we have any alkene and it is treated with the ozone, so ozonolysis takes place, we get either the aldehyde or we get the ketone here. So in short, we have already learned that whenever we just do the ozonolysis, simply what you have to do, so you just break this double bond and you just give one oxygen to one double bonded carbon and another oxygen to another double bonded carbon. So what it will become? It will become C double bond O, that's your ketone. So one will be the ketonic functional group here formed, another will be, it will be now C, H and O. So that's your aldehyde. Actually here is one hydrogen attached, you can show it. So the product will be formed after ozonolysis just like this. That is, we are having here like this. So we are having here the hydrogen, and here double bond O, that's your aldehyde, and another will be your the ketone one, that is just like this. Here it was the CH3, and then here it will be double bond and O, right? So this is the ketone. So one is the ketone functional group, another is the aldehyde. Now this is your Y, right? This is your Y. After that, what has been given? That it is treated with aqueous NaOH, that's your sodium hydroxide, that is the base. It is treated with base. So whenever we have two molecules of carbonyl compound, that's why I am having here the ketone and the aldehyde, in presence of base there will be aldol condensation. Now we are having the two functional groups within a same molecule, within a single molecule, so there will be intramolecular aldol condensation. This is very important, that what reaction will take place here? It will be your intramolecular aldol condensation. Intramolecular aldol condensation, right? So now first of all, this base OH negative, it is a base, good base. So it will just remove the proton from this carbon, from this alpha carbon, because it is your acidic one, acidic hydrogen, it will just remove. Then this enolate which will be formed here, it will just attack this carbonyl carbon, because this carbonyl carbon, it's more electron deficient. I hope you will remember that in case of aldehydes, you have to note down that this aldehydic carbon, this is more electrophilic as compared to the ketonic carbon. So it is more electrophilic. So that is why you have to remember here that first this OH, that is your base, it will just remove this acidic proton, because after that the enolate former that will attack on this carbonyl carbon, that is the aldehydic carbon here, because that is more electrophilic in nature. So okay, let me show it. So when this OH negative, it will just remove this proton. When it will just remove this proton, so the two electrons will come here on this carbon, it will be just negative. Okay, let me show it here. So it will be like this. We are here having the ketone first of all, that is C double bond O. Here it was the CH3. So it is just like this, CH3, then it is C double bond O, and then here it is now the enolate, right? Here it is the enolate. So okay, let me show it like this. So there will be negative charge, and it is resonance stabilized, it can shift here, and these two pi electrons here. Then after this we are having 1, 2, 3 carbon. So 1, 2 and 3 carbon, and then we are having here the aldehydic functional group, that is C double bond O and H, right? See, in total, there shouldn't be any confusion. For example, see, after this ketonic functional group, there are 1, 2, 3, 4 carbon atoms, right? So 1, 2, 3, and 4 carbon atoms, then it is C double bond O and H. Now, what will happen? This enolate, that is this negatively charged carbon, it will just attack on this aldehyde carbon, which is electron deficient, and these 2 pi electrons, they will just shift on this oxygen, right? So how many membered ring will be formed? It is 1, 2, 3, 4, and 5. 5 membered ring will be formed. So let me show it like this. That is, you will get this 5 membered ring like this. This is your 5 membered ring here. So here on this carbon there is O negative. So I'll write it like this. There is O negative, right? And there is the hydrogen attached here. And now here, that carbon that was here negatively charged carbon, which has attacked on this, there is C double bond O and H. So let me show it like this. That is C double bond O and CH3, right? Ketone. Okay, now what will happen? There will be now workup. So I hope you know in organic chemistry what is the workup. Workup simply means here that it will just take H positive from any solvent, right? H positive, this O negative. So it will just become your OH group here, alcohol, right? So I will write it here that here it's now your OH, isn't it? And here we are having C double bond O and CH3, right? This is your what we called as aldol, right? It is, if you just call this as alpha beta, right? Alpha beta. Now we are here having one hydrogen. On this alpha carbon there is one hydrogen, right? So this hydrogen and this OH, upon little bit heating, what will happen? There will be just removal of water. Okay, let me show it on the next page. So what we are actually having here, we are just having here, it is the 5 member ring like this, and after we are here actually having OH group, alcoholic functional group, and here we are having the ketonic functional group. So now there will be just the elimination of water molecule, a little bit heating is required here. So there is actually H. So this H and this OH, it will just come out in the form of water. So it will be now just formation of alpha beta unsaturated ketone. So that is your aldol condensation, right? So this will be your the product which was actually shown in your question. So here will be the double bond. So that is your, it was actually alpha beta. So alpha beta unsaturated ketone. This will be your the final product. So this is known as aldol condensation. Why condensation? Because actually here water molecule has also got eliminated. So it is your aldol condensation. So I hope that you have just enjoyed and understood how actually the mechanism of this reaction takes place. So thank you for watching.